Hello everybody, I will start my today's another coding practice. So I will solve this question in this video. Range some query to the mutable. So in this question, I will give him a 2D matrix. Then I have to handle multiple queries. So they update the cell, value of the cell in the grid. And also I need to handle the query to calculate the sum of the given range. So I will be given row 1, column 1, which represents the upper left corner cell, and also lower right corner cell, which is row 2, column 2, and then I will get the range sum of that given query. So that being said, I actually know the best approach for this question, which uses a 2D segment tree, or I can use 2D binary index tree. But I don't include that solution in this question. I will make a kind of compromise and I will introduce some approaches based on the requirement I will define by myself later. So that being said, let me get started. So related to this question, there is a question which is named range some query to the immutable in LeetCode. So as the name suggests, in that question, the update query doesn't exist. So all I have to do is in that question, immutable question, is firstly, I will build the kind of perfect sum grid. So in the immutable question, if I'm given like this, I will build the prefix, sum grid, which is like this. So this 10 suggests some of these 4 numbers. This 3 suggests some of these 2 numbers, 1 and 2. So which means that I will calculate the sum from 0, 0 to each cell in rectangular form. Then I will put the sum into the pre-calculated grid. Then, for example, if I'm given, say, the sum of this range, what I should do is calculate the sum of, whole sum minus this sum minus this sum from here to here. And then because I deleted 2 by 2, left top rectangle twice, I will add the 2 by 2 left top rectangle sum, and then I will get the answer. So in this way, I can handle all the sum region query in the constant time. Yeah. So that being said, this doesn't work in this question, mutable question, because even if I pre-calculate the grid sum, it will be updated when the update query is called. So I have to think a better way. Another way. And let me tell you 3 situations. I will define this situation and introduce the solution which works for each situation. So in the case update heavy, so update method call is heavy and it's called so many times, I will try to optimize the, um, execution, type complexity of that update method. So in that case, I will think that some range I will accept some range method to take so much time. So in this scenario, definitely what I would do is I just update the grid when update method is called, and just that for update query. And for some region query, I will calculate the sum of the region every time. So in that way, update query will take all of one time, constant time, but some region query can take up to the number of cells in the grid. So let me implement this first. Okay, so in that scenario, and for some region, okay, like this. So in update method, I always just update the value of the cell, and that's it. And for some region query, I will try to calculate. Every time some region is called, I calculate the sum. Yep. Maybe I can include some cache or something. I don't know, but probably this is the simplest approach. I never submit it. Oh, it's somehow accepted. Okay. Yeah, but anyway, this is the kind of, update heavy scenarios approach. Maybe I can use the cache and invalidate the cache when update method is called. I don't know how I can, design the cache mechanism for now, especially cache invalidation mechanism. But yeah, that's one of the approach. Maybe optimization I can apply. I don't know if it is possible or not. Okay, so now let me introduce the second scenario when some range heavy. So obviously this is the pattern which I can use a similar technique as range sum query immutable. So when some range is heavy, when I update the cell, also I will use the pre-calculated grid, just like I did in immutable pattern. Then when update is called, I update the original matrix and also update the pre-calculated grid, prefix sum grid. With that, some region query will take only the constant time with the formula I introduced just before. So in this way, some range can take up to number of cells. In the case when, say, this left bottom cell is updated, I have to update all this. I mean, I have to. No, sorry. The worst case is when left top cell is updated. So in that case, all the pre-calculated range sum should be updated. And for that, I will traverse all the cells. So it will take all of n time. Okay, so that being said, I will copy the matrix for now. How can I do it? I think I can do it with a row in matrix. And I will copy the row. So this copies the element. This copies the row. Completely new row is created, and because element of each row is integer, they're created. Each element is created from scratch. So this works. Okay, so this is the prefix sum, and for update method, and after that, what I should do is I think if I update, say, this 4, I don't have to update this 1 to 5 or this column 131. I have to update from here. And when I update from here, probably I think I can use a kind of dynamic programming approach. What I mean by dynamic programming approach is that if I update this 8, I mean, this 8 position in the pre-calculated grid, I need the result of, I mean, one cell below, no, sorry, one row above, one left, and this one. So I can calculate the prefix sum with this sum plus this sum minus this sum. Yeah. So this is what I mean by dynamic programming similar approach, because I use the pre-calculated result to get the prefix sum of the current cell. Okay. So let me remove that. So after doing this, so firstly I will get the def. Wait, I don't have to do in that way. Oh, sorry. And prefix sum is wrong. Oh, sorry. Wait. Okay, so I will do this now. Oh, sorry. Let me finish update method first. So firstly, I will get the def, and for each row, and for each column, which is row column or right bottom side of that. So for this, yeah, I just have to do this. and that's it. Let me move it here. So here in line 28 to 31, I updated the prefix sum pre-calculated to the array, and then in line 33, I updated the original, matrix. Okay. Oh, then in some region, I will quickly finish this first. So what I should do is so as I said, when I get the sum region, what I should get is, say if I'm taking a look at 2, 2, I will get the sum of from 0, 0 to 1, 2. Oh, wait a minute. I'm trying to get this range. Sorry, so if firstly I will get 0, 0 to row 1 column, row 2 column 2. So this is the biggest rectangle. And because if I want this circle for zero sum, I will subtract this range sum, so it should be then I will decrement zero, 0 to row 1 column 2. Oh, wait a minute. So 0, 0 to row 1 column 2 minus 1. This, which signifies the first two columns. Wait a minute, I think this is not correct. Yeah. Then also I will return. Sorry, I will add 0, 0 to row 1 minus 1 column 1 minus 1. So this is this 2 by 2. Yeah. Okay. Yeah. And one thing I have to take care is when I do row 1 minus 1 or column 1 minus 1, it can become negative. Yeah. Say if I try to get this range sum of this, yeah, I will decrement from row 0 to row -1 sum. And also I will try to subtract 0, 0. Yeah, anyway, that should not be. Yeah, I mean, row 1, column 1 can be negative. So in that case, I will just return 0. Okay, so this is for kind of base case. not base case, but just for handling the -1 case. Oh, sorry, let me just clarify with -1. Okay, good. Okay, then what I should do is implement the initialize method. So let me start with so with this row number and column number. First variable initiates prefix sum with then I will fill in this prefix sum. So first thing I can say is, basically what I try to get is so if I try to get this prefix sum, what I need is sum of this and this and minus this. Yep. However, I just have to take care one thing. So what I have to take care is row can be 0 and column can be 0 also. In that case, I shouldn't do, I mean, column minus C minus 1, R minus 1 becomes negative. So let me handle that case. Okay, so this is how it works. But I think actually this, yeah, I think this way of writing is better. I mean, in line 45, I did something like this, but let me just do it in this way because it's more easy to read. We'll fix this from now. So 0, 0, row 1 minus 1. Okay. Then I will return region sum. Okay, so let me execute my code with this. Seems right, its time limit exceeded. Oh, definitely. So, sorry, it should be set up to prefix sum. Yeah, so in this way I get the big range like this, and then I will get the target range sum. Oh, sorry, so I don't have to call some range recursively. Oh, so I was completely wrong. Wait, what am I doing? So when I call some region, I really have no idea why I was calling some region from this method. Yeah. Okay. Yeah, this is the correct. Yeah, I think. So firstly, in some region method, in line 46, I get the big rectangular size sum, and then in line 47, if there is one row or if row 1 is 1 or bigger, then I have the row which should be there removed from that big rectangular sum. And then if column 1 is bigger than 1, it means that there is a rectangle on the left side whose sum should be deleted. Then because I deleted too much, I have to, add the sum of, small rectangle on the top left. Yeah. Okay, so let me check my code. Oh, sorry, this one is not. No, this is good. Oh, sorry. So here in line 31, what I should call is not self.matrix, but self.prefix sum from here. Okay. No, this isn't correct. Check current sum. No, this should be practical. And line 32 should be practical, but line 33 should be minus equal. Because if I try to get this whole sum, and I have this one, yes, and I have this sum, and I have this first three column sum, and then I have to delete first 3 row 3 column rectangle sum. Good, now it's accepted. I will submit my code. Okay, again, this is somehow accepted. Good. So let me think of the scenario 3, which is balanced. Yeah, wait. I mean, update query and some region query are called almost, yeah, half by half. I mean, 50-50. Yeah, number of codes are balanced. In that case, I have to optimize each of them. Yeah, as much as possible. So one approach I can just come up with is I will assume that the number of rows and number of columns are almost same. And I will assume the number of rows is R. Then in the balance, my approach of the balance query, I will have the prefix sum for, so if I try to get this 2 by 2 prefix sum range, all I have to do is, let me think a little bit. So the problem is that if I update this sharp cell, the cache is invalidated. I mean, prefix sum cache is invalidated. So instead of that, I will, keep track of the. I see. So I think what I can do is I will have the, pre-calculated sum for each. Wait a minute. So this one is updated. I see. So let me think of this approach. Instead of pre-calculating the left top, I mean rectangle sum for each number, I will just keep the prefix sum for the number until these numbers which are on the left side in the same row. So for example, in this case, the prefix sum should be 1, 3, 8, and 3, 9, 15, and 1, 3, and 7. So in this way, firstly, when I have to update some number, then all I have to update is only that column. So in that way, if this is updated to 8, I just have to update this and this. So it will take only all of number column. Then for some range, so with that being said, if I'd like to get the sum range of from here to here, okay, so firstly, I guess the whole sum with O of C time, no, O of rho time. This is needed to get the whole sum. Then I will, so if I try to get this, then what I get is the whole sum. Then, because I'm interested in this, I will derive the numbers, sum of all the columns which are above that range. So it will take O of C up to O of C. Because I have the pre-calculated sum, I have to take a look at the last number in each prefix sum, prefix column sum. Then I will delete it. And then also I have to delete this 3 and 1. So wait a minute. So in that way, wait, I think I want the prefix sum for the whole row. Sorry, whole column. So if I have that, I can calculate that in the row time. Then I have to delete, say, 2 by 2. Top left. In that way, I have to see 3 and 11, which would take up to number of row. So it should be O of row plus C. So in this way, so I said I want the column prefix sum. But also I want the row prefix sums. So with these combined, I can calculate the number, range sum in O of R plus C. And also for update, as I said, I need to update column prefix sum being O, and also I have to update the row prefix sum. So column prefix sum should take O of row, and row prefix sum should take O of C to update. Because when I update, say, 11, I just have to update these row prefix sums and these columns, 3, 11, 3 columns, column prefix sums only. So it should be O of R plus D. Yep, good balanced. So No, scenario 2 is sum range. Sorry, so scenario 1 is update sum region. Sorry, sum region heavy. Wait, for update heavy, I'd like to optimize some region. So this one is the one. I think some region heavy and update heavy. So when some region heavy, scenario 1, this is scenario 1, and for scenario 2, update heavy. So, and for some region heavy, update some region should be O of 1. It should be O of n. Yeah. And for update heavy, update should be O of 1. Some region should be O of n. Okay. So from now I will implement scenario 3. So as I said, I will use column prefix sums and row prefix sums. So in the init method, and for column prefix sum, I would say wait, what I'm doing with this column? I see. Okay, I understood. So firstly, I initiate the whole, non-grid. Then I will, fill in row prefix sums. So for each column, then I will update them. Okay, that's it. And for column prefix sums, I will do the similar thing, but I will iterate row first and then column next. Wait, because for row prefix sum, I will think for each row And for column prefix sum, I will think for each column. So column prefix sum means column sum in that column. Yeah. So for column prefix sum, I will pick one column and then I will update the current prefix sum for each row number. Yeah. And I will put it in the row prefix sums, column prefix sums. Okay. Good. So this is the pre-calculation I needed for the in the initialize method. Then what I should do next is when update method is called, what I should do is I need to update row prefix sums on that column, on that row, and also save that column prefix sums in that column. So I will get the diff, and also in the end I will have the chewed value, given value. Then in line 62, I get a diff, and for row prefix sums, for each row, I will think of the column which is in the range, given column to the number of column minus 1. And then updates the prefix sum in this way. Yes. And I will do the similar for self-column prefix sums. So for each row, from given row, I will increment by diff. Okay, so this is how I update the prefix sums. Then in some region method, I will first three. Okay, so wait a minute. So let me think. I want the sum of this. In this case, what I should do is so for each row from row 1 to column 2, I will take a look at the this prefix row sum minus prefix row sum of this. Yeah. I mean, so in this case, in line 76, I will get prefix row sum 3 minus prefix row sum 1. Yeah, so that's what I should do. So that being said, I noticed that self.column prefix sums isn't needed actually. Yeah, I can completely forget it. Yeah, I don't need it. But actually, it just matters depending on the number of columns and number of rows here. Okay. So for each row, I will calculate the column sum. The column sum should be so yeah, so I can calculate it in this way. And after I get the column sum, I will add it to the return. Then I will return read in the end. Okay. Yeah, I think this works. So let me submit my code. Now, row prefix, row prefix sums. Ah, but it's not correct. So let me think. This failed after update. I hope some region is correct and update somehow was somehow wrong. Let me check. Ah, wait. What I'm doing here, up for update for each column. So probably, yeah, this one was, I implemented opposite tree between column prefix sum and row prefix sums, I guess. Okay, so let me check again. So now I think this update method is correct. So let me print out what happens. and also after initiating the, method. So firstly, when I initiate the matrix, I will check if this is row prefix sum. 3, 3, 4, 8, 10, correct? 5, 11, 14, 16, 17, correct. Correct. I think it's correct. So next, I will get some region which is correct. Then I will code update with 322. So row is 3, column is 2, value is 2. I see. I understood. So in line 64, instead of doing this, yeah, so def should be value minus current value. Good. So let me submit my code. Okay, now it's accepted. Oh, it's much faster, I think. Good. And actually, for the balance method, there is one more case, one more algorithm I can use, which is using the 2D segment tree or 2D binary index tree. And in that way, yeah, the time complexity and space complexity should be, time complexity should be log n and log n. No, sorry, this is talking about just general segment tree, sorry. So this one, log n log m, log n log m. So this is good. Yeah. I will just note it here. Yeah. So I can improve this scenario 3 approach solution to update method log r log c and also summation method log r log c by using the binary index tree. But I don't dive into that implementation today because it's so heavy. Maybe I will shoot another video for only for that. Yeah, but I will just quickly notice that. Okay, interesting question. So I will quickly wrap up and finish my video. So I solved the question, ran some query to the mutable, and in this question, I will handle 2 queries, update query and some region query. And I introduce 3 approaches depending on the scenarios. So if the sum region method is called heavily, which means that I have to optimize some region query. So what I can do is let me solve it. Yeah. So what I can do is like this. So where is it? So okay, so when some region is called heavily, which means that I have to get some of the region quickly. So I will calculate the range, rectangle range sum of the top left for each cell. Yeah. Then I mean for updating this prefix sum array, to the array, update method will take O of n time. I mean, O of r times c, yeah, time. And for scenario 2, update heavy, so because I'd like to optimize the update query, I mean, for update query, I just update the matrix value. And then in the sum region query, I will calculate the sum of the region by taking a look at each cell in that range in a kind of brute force way. Yeah. So it will take O of 1 constant time for update, but O of n number of cells for sum region query. And in the scenario 3, when update query and sum region query are called in a balanced way. So in that case, I'd like to optimize each of them. So I use the approach that I use the row prefix sums. So I mean, for each row, I calculate the prefix sum. Yeah. So by using that, update query takes O of c time. C is the number of columns, and sum region method call will take O of r time. This is used because I have to take a look at each row in the range, and then from that I can use the row prefix sums to get the range sum of only in that row in a constant time. So it will take all of our time. Okay, so that's the wrap up of this question. Oh, and for the third balanced, scenario, I also can use the binary index tree, which will optimize the time complexity to log r log c, which is so quick. But I omitted the implementation in this question. I mean, in this video. Okay, so let me finish my today's video with this. Thank you so much. Bye.